I'll be doing problem number 12 on page 588. Suppose you wish to fabricate a uniform wire out of 1 gram of copper. If the wire is to have a resistance of 0.5 ohms, and if all the copper is to be used, what will be A, the length, and B, the diameter of the wire? So there are some givens that we should look for, such as the resistivity of copper. And if you look it up, the resistivity of copper is 1.7 times 10 to the negative 8. And you're actually going to need the density of copper, and you kind of get the hint that you're going to need it because they have grams, and you want to find the diameter, or that because in this formula it has area, which is basically the cross section of the wire that you need to make the copper into that the current will flow through. So that kind of gives you a hint that you're going to need density for this, because basically that cross section area, I'm going to draw a diagram so you can visualize it. You're eventually going to use this equation, but the area stands for, all this area of the copper wire which the current's going to go through, and that's basically the volume of the cylinder. And you have 1 gram of copper, so with density you can figure that out. But first, let's just start with this. We want to know the density, and we need to know the length of this wire. So we'll start with this right here. They said the wire that you're creating has to be 0.5 ohms. You know the resistivity is 1.7 times 10 to the negative 8. You have no idea what length is, you're trying to solve for that. And you don't know what area is. But, you can't really do much to length. But for area, you can come up with an expression for it that has something in terms of L, so that we can start, combining this. So how can I get an expression for this? Because like I said earlier, area is the cross section which the current has to go through, which is basically the cylinder's volume. So let's write out the formula for a cylinder's volume, which is pi r squared times the length of it. But since we don't have the radius, I'm just going to use diameter divided by 2 squared times the length equals volume. And so you have 1 gram of copper, and 8.96 grams per cubic centimeters is the density. So with this and this, one way we can write it is like this. Because the units will check out here. You got grams per cubic centimeters, and you got 1 gram. So this is how you would write it. And you're trying to get rid of grams, the units, so you don't have to deal with it. So the math will check out. And we'll go ahead and copy this again. And so we can just move the L over. Why are we moving the L? I'm also gonna stop writing units to make it simple. You can move L here because L is gonna be in meters, and even though this is in cubic centimeters, well, you can convert that to meters cubed, and this is meters, and that will cancel some units. So if you convert 1 cubic centimeter to meters, you will get 10 to the negative 6 cubic meters over 8.96 times L, and L is in meters, so that will work out. So now that you have an expression for the area or the cross section of which the current must go through, you can put it back into here. So once you have this, you can do a little trick and just move it up there. I'm gonna start writing units, and the ohm isn't like, has its own units like meters squared and all that, so we won't worry too much about that. All divided by 10 to the negative 6 multiply just the coefficients at the top, and you will get 1.523 times 10 to the negative 7. 10 to the negative 7. And with 10 to the negative 6 at the bottom, you can cancel those out. And you'll be left with 1.523. Oh yeah, L squared. Forgot to write that. 1.523 times 10 to the negative 1 L squared. And then L squared by itself is just 3.28. Once you take this whole thing divided by 0.5, square root that, and your length is 1.81 meters. Now you have L here. You can go back up here and plug it into here to get and solve for D. We'll isolate D here. So you have 10 to the negative 6, 8.96 L. And since you're dividing by pi, this whole thing divided by pi, you can stick in a calculator and that will work out. D is just 2 times the square root of this entire thing. .81, plugging 1.81 meters for L now, all divided by pi. Square root this entire thing, then multiply by 2, and you'll get 2.8 times 10 to the negative 4 meters. And the only sensible way to write meters, because that's so small, you're going to want to write it in millimeters. Do some unit conversions and you'll get 0.28 millimeters. That's how you do problem number 12.